We will see Adam Scotch from Brewer Science, tech leader, material scientist. He can do everything. And he will share with us today the path towards ubiquitous water quality monitoring.
Very good, thank you. I'm Adam Scotch at Brewer Science. First, I have to say that I had a small chuckle when I first saw the proposed title of the talk, because I would never use the word ubiquitous in a technical talk ever. But actually, the more I thought about it, the more it actually was in line with where we're headed at Brewer Science. So I made a small change towards ubiquitous, because we're not quite there yet, but so towards ubiquitous water quality monitoring. So I'll go through and explain, what I mean by ubiquitous. So ultimately, at Brewer Science, we are driving towards a low power, low cost water quality sensor or water quality monitor that would enable us to distribute our sensors across a wide geographical area, so that we could, in real time and continuously monitor our precious natural resource. So we could monitor the lakes, rivers, and streams as time goes on, and create heat maps across the world, so that we could see what's happening with our water system, and in particular, what is the quality of the water. Right now, the current environmental monitoring process is actually very slow and expensive. There is no inline monitoring solution that can capture in the parts per billion range, in particular for heavy metals. Water samples, as shown here, are collected manually, often on an irregular basis. So you only are able to get a single snapshot in time of what's going on with the water. Those samples then are usually sent to a lab, which can require buffering and a skilled technician in order to process it in a machine. The laboratory testing itself can be actually quite expensive and can take days or weeks in some cases, depending on what you're trying to measure. And this is not good when you're trying to create actions in monitoring your water quality, in how to treat your water or how to monitor your water for environmental reasons. So this is where we come in. We've started developing what we refer to as the Inflect water quality system. Our whole goal here is to make a repeatable, continuous inline monitoring system. So a schematic is shown here on the left. The real basis of our system is centered around what's circled down here in this sort of flow cell and printed circuit board. Inside this flow cell is the water sensor. The water flows across and measures through an electrochemical process. We have our own circuit, which is attached to that to capture that data and then transmit that to a wireless device, so that you can take action when needed. So this is a zoom in of the actual sensor. This is a water sensing array. So on this array, it's basically a substrate, which we have multiple electrodes mounted on here. So we have a reference electrode, and we have a series of electrodes, and we can add as many or as few electrodes here as we like. And each electrode can measure an individual analyte that we're interested in measuring. So, for example, we can measure nitrate or dissolved lead that's in our water, or measuring pH. We automatically measure temperature and conductivity, that is sort of ionic conductivity, to allow us to compensate for some of our measurements through our algorithms. So this is really the core of our system. So if those of you who know Brewer Science, you might be a little confused, because Brewer Science has been around for over 40 years, and our basic business is really around advanced lithography, materials for advanced lithography for the semiconductor industry. But that's actually why we think that Brewer Science is well positioned for helping in water sensing. And this is the primary